Imagine playing a co-op shooter like Fortnite or PUBG on a VR headset in real time, with zero lag all through your phone while traveling in a fleet of self-driving cars going 200 miles an hour. Sit tight, because the future of gaming and everything else is about to change forever. If you look up into the corner of your phone, you're probably used to seeing a little indicator that says 4G LTE, or 3G, or God forbid, 2G. And you've come to understand that it probably has something to do with your phone's connection to your mobile network. The higher the G, the faster the connection. It's pretty easy to follow. The G stands for generation, and each subsequent generation refers to a specific minimum speed, connectivity, and reliability necessary to classify that network as a particular generation. 1G let us talk to each other. 2G let us send messages. 3G gave us broad data and internet, and 4G LTE made it a whole lot faster. But all that's in the soon-to-be past, because up on the horizon is 5G. And while you may be thinking that 5G is just a little faster, a little more reliable, and a little newer, it's actually a massive breakthrough that's going to change the way devices connect to the internet, and more importantly, to each other. In fact, as 5G rolls out over the next 2 years, it's going to change, well, everything with a wireless connection, which at this point is, well, pretty much everything. So what's so special about a 5G future? Well, first of all, it's fast. Like, really fast. Like 20 gigabits per second over wireless fast. Like 100 to 250 times faster than 4G. Because by comparison, 4G provides speeds, on average, of about 10 to 20 megabits a second. So that's like going from streaming one Netflix movie in HD to streaming 400 movies in 8K at the same time. And while that's really impressive, that's not the most impressive part. What sets 5G aside is its crazy low latency rate, which is the amount of delay between the sending and receiving of information. Now, 4G tends to average about 100 to 200 milliseconds, and to be fair, 100 milliseconds is fast. Human reaction time is about 200 to 300 milliseconds, but 5G will get it down to 1 millisecond. That's almost real time. And being able to send and receive information in what is essentially real time means that we can use 5G to replace real-time interactions. What does that mean? With 5G, you'll be able to interact with people, objects, or characters controlled by someone else with no lag on either side. So play a real-time first-person shooter on your phone. Control virtual objects with other people simultaneously. Put on a headset and fly a drone or drive a car that's somewhere else in real life. Or, better yet, let it drive itself. That might be one of the biggest breakthroughs in 5G, a network of self-driving cars all sending data between each other and communicating with traffic lights, road sensors, aerial drones, and so on. Think about it, human reaction speed is 200 milliseconds and we still have accidents every day. Imagine if your car could react and communicate its reaction to hundreds of cars around it, all within a millisecond. Not only could we end car accidents, we could end traffic altogether. Hundreds of self-driving cars going lightning fast to your destination with no risk that they'll hit each other because they all know exactly where they are in real time, reacting to the actual world around them. Autonomous or remotely controlled trains, delivery trucks, even airplanes could be on the horizon in the near future. In fact, forget cars for a second and think of all robotic devices. Surgeries could be performed from the other side of the world with robots controlled in real time by expert surgeons being assisted by other expert surgeons in other parts of the world simultaneously. That could be saving lives in situations where time and distance are the difference between life and death. Factories can be staffed by robots that can communicate their task and position to each other, allowing them to not only do more, but do it more efficiently and wirelessly over a 5G network. Imagine a fleet of drones flying over a field of crops using sensors on the ground to sort, pick, feed, and water individual plants, all on their own. 5G will revolutionize the future, and companies have already spent billions to set up their networks and to fund new technologies that can use it. But that's not to say 5G is perfect. One major drawback has to do with why it's so fast. See, 5G uses a mix of frequencies, with most of the attention on the brand new millimeter waves that are compared to the 15 to 40 centimeter long waves used by 4G. And shorter waves and higher frequencies have a massive problem. They don't go very far. Whereas on a 4G network you can go 10 kilometers and barely lose signal, 5G maxes out at about 300 meters, and it can't go through walls, or even bad weather like rain. So what does that mean? Well, it's a gift and a curse. Having such a short signal distance means building more transmitters. A lot more transmitters. Like multiple transmitters every couple of 100 meters in every direction. On the other hand, it also means that you can pack more devices into one area. Now, 4G allows connectivity to 1 million devices in 500 square kilometers. That's about the size of Chicago. 5G, on the other hand, will allow 1 million devices in 1 square kilometer, or a little smaller than Grant Park in Chicago. So, how far away are we from reaping the benefits of 5G, self-driving fleets, and robot surgery? Well, at least a couple years. 5G is expected to be fully rolled out by March of 2020, and over the next 2 years will be slowly phased in and experimented with as sensors and transmitters are installed around the world. Some companies, like T-Mobile and Verizon, have already launched home 5G networks in select cities. But it'll still take quite a bit of time for all the new hardware, software, and brand new innovations to work seamlessly together. Until then, we'll just have to keep dreaming of a bright, new 5G future.